config. Do we need this? Is this something we need? It would certainly be nice if we didn't have this little pop here. This is a lot of stuff. This is a lot of stuff. Model is here too. Oh, we're implementing the model. Are we doing create? Okay, here's the model. Got it. Okay. Forward classification. Output. So okay, got it. Understood. Okay, so we need to define a forward classification, which is going to be used to capture the output. All right, and then we return a new class out with the loss, the output, and the targets. We're making things happen. We're just learning today is what we're doing. We're learning. We're understanding how the burn library works. Auto diff backend, huh? Is that what this is? All right, let's step in. Train step classification. Wow, that's a lot of stuff here. Oh, okay, got it. Here's the step. Okay. So this is going to be, is this accurate? So this will run the output classification from a, this is a lot to train. It's so much easier to use PyTorch. It's so much easier to use PyTorch. It's ridiculous. All right. Data loader. Where do we post the data? Okay, data train, learner fit, loader train, data loader test. Okay. Do we need two things here? We got to do test and loader at the same time. How does shuffle work? Oh, config seed. Okay. I was actually going to say, because I'm like, you can't shuffle the two data sets separately. You have to keep them in tandem. Are we not doing what we did for stock prediction? Yep, that's what we were doing. Geechee Man. Geechee Man is here. What's up? Hey, Geechee Man, good to see you. We are definitely doing the stock prediction, but we're trying to get everything set up. It's not an easy, quick, simple setup. So we have a lot to do. I want to just train it. Why does it have to be so complicated? Valid step, backend. So what do we need here? We need this. I know we need this part right here. So let's go ahead and copy and paste this piece right here. Let's copy and paste that and put that into our code over here. So as we need to implement a classification thing here. Sorry, set paste. All right, set no paste. No, I don't know what that did. Set no paste. Perfect. Okay. Here, what we got here? Model. All right, model. Good. All right, back end. All right, so this is the input. This is the targets, right? Input will be 2, I believe. Targets is going to be 1. What is this? What is this right here? What is int? What is int? int. What is that? It's just there. I don't know what that means. Is it a? It should be a float, right? I assume it's a float. Okay. Do we have to? Does it have to be an int? I mean, it should be. It should be here. You know what? Let's do that. Let's make it an int and let's turn these off. These will be ints, not floats. I assume. I don't know. We'll find out if that works. I don't know if it will or not. We're just organizing everything here. All right. So probably do this. Probably have use Atom config, whatever. We don't need Prelude again. I don't know what that is. So let's just hide that for now. I don't know what that is. Auto diff backend. I don't know what that is either. All right, train, classification, linear builder, linear strategy. Wow, there's just so much stuff here, you guys. There's so much stuff. I can't believe it. All right, we probably don't need all this. All right, hide that. I know we don't need this either. Can I do MSE? Is there like an MSE? Because for what we're doing, we don't need this. We need something else. Can we do mean squared error? Is there something like that? I assume because this. All right, so you can do mean squared error. Is it like? I assume. I don't know. We'll find out. Reinitialize every forward classification. The cross entropy config. This seems like a problem. To do cache in model. Well, maybe a model training struct or something like that. Right? We probably want to do something like that. Because why continuously for every single output reinitialize the config for the cross entropy loss? Like, why do it? Because you have to, and then you have to put it to the output device, and you have to forward it, right? One just create it once. Or does it always need, you always need to do it? So classification output new. Like, this seems wasteful. It seems wasteful. Is it going to build? Okay, we got an error. We'll be able to fix it. We'll fix it. Oh, MNIST batch. Okay, so we know we're not doing anything with that, so we're going to have to figure that out. Auto diff backend not found in scope. We'll probably have to fix that as well. Is that because we commented it out? Here we go. We commented it out. Let's just bring this stuff back. This doesn't exist. That's not a real thing. We need a different, this isn't going to work for us. We need something different here. To do MSE. We need MSE, you guys. We need MSE. Yeah, because for what we're doing, it's not going to work. For the real, it's just, wait. Oh, the double colons is just, yeah, I know. It should just be period. It absolutely should be. You're totally right. It absolutely should be. Let's see if we got rid of some of the errors here. Let's rebuild. Obviously, we didn't fix everything. So we're not doing MNIST. So we need, so we've got a problem here. I don't want to do MNIST. I want to do my own data set. Why does it have to be this hard? And why do you require to set a generic here when you're implementing a function in a model like this? When you're implementing a trait, why, oh why, do you have to specify the data over here? This is the problem I have right now. The problem with like these abstractions, it takes it too far. It takes it too far because now I have to do all this extra work to satisfy the abstraction. It's like labor. It's extra labor. What are you stuck on? Oh, so right now we're getting training. So the goal for today, Nebo, is to get the XOR. So here we want to train on this data. Check this out. All right. So we mostly have everything good. So we want to train on this data right here, right? Simple XOR, is that correct? Yes. Do now is implement something with the train step and a batch here, which is really confusing. So I don't know how to deal with this. This is where we are. Yeah, burn API is weird. I don't get it. All right, that's where we're stuck too. I know. That's what we want. So the MNIST batch, we need to change it with our own batch, essentially, with our very own batch. I upgraded these things, I assume. I don't know for sure. I wonder though. I wonder. Here, let's comment some of this stuff out real quick, so we can see if we can rebuild this. I want to test something. I want to test something really quick. All right. Looks good. Just a bunch of warnings. We're all good. Okay. All right. So forward. Where is that at? Here we go. Forward. All right. The output. I wonder if we could do 1, int. Is that what we can do? Is that the same thing, or is that different? No. Okay. All right. So this is something else. It's not what I thought it was. It's not what I thought it was. I mean, it's a different shape. So here, check this out. The shape that they're looking for is batch width and height, right? So it's a 3-dimensional array. And the output that I have is, and that's just for, right, that's the input. And the output will be batch and then a single number, and then a single dimensional array. So that'll be 2. However, they seem to have it different. What we could do though is I guess we could try it. Create MNIST batcher. All right. So what we could do is, since this is in the local crate, we could probably snag this. So this is another file. Let's grab this. All right. So MNIST batcher is what we need. MNIST batch and MNIST batcher. All right. We can grab that. It should be in somewhere in here. Data. Was it in data? Hold on. Let's go back. Where was that? In for training. Here we go. Data. It was. Okay, so it's in the data file. All right, let's in the data file. Let's see. Do you want the model config? No, the actual model. Where's that at? Where do we put that? Where do we put it? Is it around here somewhere? Here it is. Okay. All right. Forward, right? So 2 and 2. Perfect. It's 2 and 2. So we should be able to change that, and that should be good. So where was that at? Here, 2 and 2. That's what I thought it was. All right, so it's batch. Nice, easy, relaxing jaunt with the burn library and Rust. So we don't need to do any of these normalization steps. Also, this is data pre-processing, right? We don't need to do any of that. None of that needs to happen here. Images, items, targets. So we could probably, all right, so this is what we got to do. Okay. MNIST item. Where did this come from? Where's this at? Oh, great. Now we got another abstraction to deal with. Come on, guys. Let's see here. Also, we need to see, where is that at? All right, so vision MNIST item. Oh, okay. So this is just part of, it says data set. So this is just extra data, right? That comes with the library for, testing purposes. How do we deal with this? Items, batcher, items, device. All right, so device is fine. MNIST batch, MNIST item. So we've got this. We've got this class. We're good there. Or the struct, rather. We got the struct. MNIST batcher, which is empty. Just empty. How about we... Let's see here. Yeah, you just need the collect. All right, cool. Just the collect. So we could just delete the rest of this. Boop. Like that, right there. Explain. Here we go. Watch. We'll do this. Here we go. Watch this. Because you said the tick man. Explain the Rust code. All right. Let's see what it says. All right. Yep. Item.label. Obviously, I know what it's doing. It's abstracting the label data, the output data from the image set, right? It's going to be a class. It's going to be a class between 0 and 9, right? So it's a 10 possible classes. I know what that is. This creates a tensor using a backend B with a rank 2, two-dimensional tensor. All right, so we figured that part out, right? We know what we're doing. B usually something like indie array, GPU, and burn auto diff. All right, so that is going to be the backend B. All right, so what device is it going to run on? All right, we got that as well. 2 means the tensor must behave like as a matrix, even if it's 1 by 1. Got it. All right. Rust is the learning curve. It's a cliff. It is. You got it. It's a cliff. Here's an int element. All right. Let's pull this up here so we can see it. This converts a Rust primitive I64 into the backend specific integer. Oh, really? What do you know? All right. Sounds good to me. Makes sense, I guess. Backends often have their own element types, GPUs, quantifiers, and things like that. Ensure the number is turned into a B int element so the backend can store it. This wraps the element in one element or Rust array. This triple dots. Okay, so where were the triple dots at? Did we see triple dots? Is that even in here? Is it hallucinating? 'Cause I don't see it. All right. Is that here? Okay. Let's grab that. Go like this. Okay. So here's this. I don't see any triple dots. All right. Sounds fine with me. Device. Okay. Label, convert, pack into a 1 element array, creates a rank 2 tensor array. Okay. I mean, it helped a little bit. You're right. It helped the smidgen. It did. We helped the smidgen. Triple dots is never a thing. Oh, got it. You made it. So we've defined this, right? Oh, no, we didn't. That is coming from a data class here. So we could just grab it, I guess, and then inspect it. Like Nevo is describing, we should grab it. All right, where's the data? Data over here? Okay. All right, so we grab data. Let's pull this out here like that. I believe we can go like over here. All right, so we grabbed our data. Data loader batcher, data set here. Do we already have the batcher? Implement batcher for MNIST. Okay, so we needed that. We needed that anyway, so I'm glad we grabbed that. I'm glad we grabbed it. Okay. Could we, I suppose we could keep all of this here, but I don't want to. This is going to be rough. This can be rough. Okay, I think we can do it. You need your own because you're not doing images? Yeah, we do. Neville, you're absolutely right. We absolutely do because it's a different dimension. Like the class. Oh, have you tried using AI to transfer Python projects to Rust yet? Oh, I have not. That's actually a good idea, Kyle. It is just easy transcription. Have the AI translate the code to another language. There you go. F64. All right, so I do batcher.batch. Self is going to be MNIST batcher, which is here. We're just creating a batch function here. And the problem is I need to see where it's run so I understand. So then I can understand. See, there's a step here. And then we're getting another batch. So what's happening here? Why is this basically defined twice? What's going on? So valid the step, train the step. Okay, so this is the training step. And this will be a validation, which does the forward classification again. Okay, so this will be for the test data probably, right? So that's the test data. Struggling to get the burn library to work. The challenge with the burn library is it's just the amount of code you have to write in order to use it is over much. It's a bit too much. Important. You need to have the input and the output. Yes, exactly. Yeah, we need the features and the labels. Yeah, exactly. We need the features and the labels. So what I could do is I could just merge the data when I'm throwing it into the batcher. The thing is, where's the code being called? Like, where is it happening at? Like, I'm not seeing it in here. Like, where is it happening? So I've got this. We could just, what we could do is say features labels or something like that. Or we just merge it together. We can just merge the data. So that way the first two elements of the array are the input data and the third element is the output. So that way each item, as you're training each sample, will be in the same shape. So that's what we could do. We could do that, right? So here we go. So let's do input output. So let input in output, like we could combine these, right? So let's say in out. Let's keep it like third element. So this is a 1, and then this will be a 1, and the last one is a 0. All right, perfect. Here we go. Okay, so we've got the in out. Works for me. Now it's in the right shape. That will work for the batcher that's expecting all of it's all in one spot. But you always also work, both are fine. Then you can loop iterate, have items be items input. Oh, input and output. Oh, got it. Yeah, that could work. Yeah, that could work. We could do that too. I like that idea. Neville, your idea is better than mine. I mean, I was doing like this. Your idea, I like your idea. So we can create a vector with input output, and that would, let's look at it over here. Where is that at? Item. Oh my goodness. So this is a problem right here. Where is that located? Yeah, now the parts that I do not get are this implementation of the trait. So I guess we're stuck. I call this being stuck right now because I don't know where to go from here. I suppose we could just not do this right here and we can just do the MNIST. Let's just try to see if we could do the MNIST. But then we have to redefine everything. It's not what I want to do. Take them as a tuple. We could do as a tuple. Yeah. See, I would love to do that. The problem is, where would, I guess right here is what you're thinking. So items could be like this. Is that going to work? See, the thing is, I don't know where, right. So I think this is what you're saying, right? Tuple vec, F64. And then there you go. So we got items like that. That'll work perfectly fine. I'm perfectly fine with that. The challenge is this function is not being used anywhere. Batch. It's just not used. It's never called. It's never been called. So I don't know where to put that data in. That's part of the problem. Let's see, inference. So, all right. So we don't need to worry about that. Data. Let's see here. All right, see if the batch is in here. Batch. Nope, that's just where we were. All right, so not in data. What about lib? What's in lib? Nope, nothing in there. We're looking for the batch. Oh, hey, here's batch size. I've been looking all over for that. Where'd that go? All right, training config, batch size. Oh, where's the batch? Batcher default, batcher.clone. C, Okay, validation step, batch. It's just so much code. It's just so much code. And I do not. All right. Here's what we're going to do. Since how much time do we have left? All right. So we've got about 15 minutes or so. What I would like to get something that is at least working. So what I'm going to do is I'm going to clone this. I'm going to clone this repository, and then we're going to make our way into this directory, and then we're going to build this project, and we're going to train it. So that's what we're going to do, and then we're going to see how it works. I think that's the next step because we want to keep moving forward. We don't want to get stuck. So let's at least make some progress here. Perfect. Okay. So what we're going to do is let's go to the main branch. Let's see. And there's examples. We got all these pretty beautiful examples in here, right? So we got all the examples. So let's clone this. If we run this, that'll run on, features on the CPU. All right. Torch GPU. I wonder if we could throw it on the metal or export CUDA. Okay. We do not have CUDA, so we cannot use Torch, I guess, apparently. We can do India Array. This should work fine because that's just CPU. It will take a long time to train, though. I think it's just a little bit longer time to train. All right, so let's see if we can run this here really quick. Hold on. All right, let's see if that works. All right, so we'll compile it, and then is that going to build it? Hold on. Is that going to build? Oh, wait. Are we going to build or run? Are we building or running? I forgot. Oh, we're running. Okay. So this will build and run it all at the same time. Let's see what it does here. And then we can look into some of the code. All right. While that's working, burn examples MNIST ls vi. WGP would work. Try it. Okay, we'll try WGPU. All right. That's a good idea. Let me this is for WG. Okay. Use this. All right. So we'll try this one right here. That's a good idea. All right. We'll try that one. Okay. So we'll let it finish building. And then we'll use WGPU. Web GPU should definitely work. Cross-platform accelerator. Oh, wow. Oh, hey, look at that. Oh, whoa. Isn't that pretty? Okay. Do you guys see this? It was unexpected. Look at that. That's very pretty. All right. If this is what we get, I am kind of into it. All right. So this is, what are we looking at here? We're looking at accuracy. Can we change it to something else other than accuracy? Loss. Okay. So that's the loss, learning rate. Can we see the learning? All right. So here's the loss. So that means we're still learning. And we got our accuracy here, which probably improves over time, 44%. All right. Looking good. Let's try WGPU. Let's try WGPU because this is taking forever. Close, please. Cancel, please. Cancel. It's not canceling. All right, let's see here. Close. Yes, cancel, please. Where is there? Q. Okay, Q for quit. All right, I'm pressing Q. Yes, Q. Stop training. K. All right. Whoa, what's going on now? What? Whoa. No. Q. K. All right, there we go. It's got to rebuild everything now. We're going to rebuild all of it. Okay. Let's see here. Okay. Let's see where we get with this, you guys. Let's see where we get. I'm actually kind of excited. It should build a lot faster. And we get I was not expecting that. I was not expecting to see a wonderful user interface that shows a beautiful display for the current accuracy, the training, the loss, and the Rust being very fast. Yeah, I know, right? It's very fast. I mean, it's as fast as it can be, right? It can't get any faster. The tension. I know, it's the tension. It's there. It's only one library away from building. All right, let's see if if we're gonna get the WGPU on it. We'll see if we get WGPU. Kyle. I mean, it'll be a little bit faster than, say, Python for sure. And it was working. And it was training on the MNIST data set. So, I mean, that's quite a bit of data. Let's see if we can get the WGPU going for here. Let's see if we can get the WGPU. All right, so is it going to work? I mean, it's trying. It seems to be trying. All right, let's see here, HTOP. Let's see what we got. What are we running here? It looks like it's trying to do something, I guess. or it's not working at all. That's one of the other things. It might be working not at all. Oh, there it goes. Okay, it just took a long time to set up. Oh, that's a lot faster. Hey, we're doing it now, aren't we? Oh, and it's using all my CPUs. Oh, that's gonna cause some. Wow, look at that. 100% across the screen. Is my stream doing okay? It's using every resource available. Our training an AI model to this is optical character recognition, and it's already learned. It's already done great. I thought it was really neat. So what I want to do though is we need to transform the example into something that I could use. And we're trying to learn the burn library. So at least we got something that works. At least we got some training. It didn't train my data. It's training sample data, which is, for tutorial purposes, right? It's for tutorial purposes. I like the burn library. It comes with really good user interface, a good experience. We just need to get it to work for our own purposes. So, hey, how's it going? Mayua, we are training just sample data right now, and we're learning the burn library. So we're learning the burn library. We did pretty good. We're making progress. We're figuring small little things out, a little bit here and there. Is that BTOP or is that something else? It's something else. So the burn library comes with a built-in a GUI, essentially, a GUI for your terminal, or a TUI, right? Terminal user interface. It's a terminal user interface. And it's very nice, isn't it? Isn't that nice? Doesn't that look great? You can see the progress, the percentage, the amount of time taken, the loss, the accuracy, the learning rate. It's very, very satisfying to see this. And so all you have to do, though, is you have to write a whole bunch of boilerplate code in order to take advantage of it. And that's what we're trying to learn. The UI is nice, isn't it, Kyle? I thought it was nice. I think you might want to read up on how traits and iterations work in Rust. Yes. That sounds like a good one. That's a good... would really help you with the boilerplate. It seems like it. It seems like it. You're right. I'm with you, Nevo. That would help a lot. I think you're right. Dabbled with it before then, but I only really started heavily using it in 2019. So that's about 5-6 years. I've avoided a lot of the generics and other advanced capabilities of the language because I tend towards minimalism. Even in JavaScript or in Python, I don't like to use the advanced capabilities of abstraction. I like to avoid the abstraction, the capability of abstraction, because it adds a whole bunch more just text on the screen. And usually, for the most part, you don't need it. And I've been able to achieve it very well. Success without those things over many years. What we did today, I think we got some stuff going, although our code was just, my goodness. We're just trying to get something simple. Wouldn't it be nice to have a very simple hello world example for the burn library instead of this rather large 400 lines of code that we need just to run the MNIST training data set? Seriously, the Keras, here, check this out. This is Keras. You're looking at this screen right here. Let me zoom out. Here you go. Here's all the code you need. 100%, you're looking at 100% of the code right here on the screen. Obviously, you can't read it because it's really small. Most of it is just text. But if you look at it, there's some code here, there's some code here, a little bit here, and a little bit here. That is the exact same thing that we're doing with the burn library. And the challenge is, so you check this out. Look at this. Just take a peek at this. QK, all right. Watch this. LSSRC. All right, so see all these files here? This is ridiculous. All right, so let's see. CD SRC. Can I see what is that? WC star? Look at this. All right. Look at this right here. See, I told you it was 400 lines. I wasn't joking. It's more than 400 lines. It's 600 lines. 600 lines of code in the burn library versus the Keras over here. You're looking at, I don't know, maybe 70 lines of code. It's like night and day. It's completely different. So that's what we're struggling with right now. We got things kind of working. I didn't succeed as much as I wanted to, although I'm actually pretty happy that, we got something built. We've got a known good working example, and Nevo is going to write for us a very simple burn library or burn implementation of, cool, SAQ